Peace be upon you everyone. Welcome to my progress report presentation. I am Muhammad Nur Alafi bin Muhammad Usaini from Faculty of Electrical Engineering. I am doing my research work for my Doctor of Philosophy in Electrical Engineering under supervision of Professor Madya IR Dr. Suzilawati Yusof, College of Electrical Engineering UITM. Doing research of evaluation of metal organic framework coated optical fiber for water pollutant detection. On to introduction. Surface plasmon polariton are optical surface wave typical propagating along a metal dielectric interface due to electronic oscillation excited by optical frequency in the metal and metal oxide, such as gold with zinc oxide, when the excitation frequency matches the resonance frequency of the SPP, which is surface plasmon resonance behavior is observed. This resonance condition is highly dependent upon several variables, including the refractive index of the surrounding material, as well as geometry of the studied system. The former has allowed variety of optical plasmonic sensors to be developed, with so-called Craftsman Prism configuration being the most mature platform to the point of commercialization. This configuration, however, suffer from typical drawback associated with free space optical systems, such as relatively complicated and bulky component, as well as complicated operating and maintenance procedure. Surface plasmon resonance sensors have numerous applications in the discovery of poisonous gas, water, toxin, and biomarker of numerous infections. Surface plasmon sensors are great at candidate for the future detecting stage due to the high sensitivity and fine resolution. Hebio Jr. Bezerra de Oliveira indicate that simulation on plasmon D-shaped fiber optic sensor during console multiphysics simulation needed to calculate the mode of wave propagation in the optical fiber, where this mode depends on the wavelength of the electromagnetic radiation and the index of the refractive material. Emranul Haq tell that there are need to notify range of refractive index detecting capability of highly sensitive SPR sensor. Wastimala Yasudasu expressed there is need to understand the performance of sensor to find detection of refractive index. The objective of this research project are as followed. Firstly, to investigate theoretical investigation of optimal design for D-shaped optical fiber sensor excitation using side polished optical fiber using console multiphysics software. Secondly, to investigate the sensitivity of the fiber optic bare and with different refractive index. Thirdly, and the final one is to implement plasmon fiber optic sensor. Next one is, by reviewing previous literature, Farhan Mumtaz summarized that the reported SPR sensor has a simple structure, dual parameter, sensing capability with a wide range of RI refractive index detection capability, and the highest measurement sensitivity. In addition, the report sensor exhibit a high measurement resolution of refractive index. Next one, Emranul Haq indicate that gold as a plasmonic material is created on one side to make two passageway in such a way so that evanescence wave can enhance resonance effect significantly to the guided along the interface in the form of a traveling wave. Thirdly, Hebio Jr. Bezerra de Oliveira notified that console multiphysics software by the finite element method (FEM) can perform computational modeling for single mode D-shaped optical fiber. we moving on. Research methodology. Firstly, console multi-physics simulation. The workflow is straightforward and can in general be described by the following steps. Create or import the geometry. Select the material. Select the suitable wave optic interface. Define boundary and initial condition. Define mesh. Select a solver and visualize the result. Electromagnetic wave modeling requires highly specialized boundary condition, including the capability of modeling unbound domain as well as periodic structure, such as metamaterial, to simulate and study plasmon optic sensor performance. The next research methodology that performed was wavelength monitor. The process involved place the D-shaped fiber optic between the white light source and the wavelength monitor. The recorded result was saved into pen drive that connected to the device. The wavelength monitor helped monitor wavelength on the different value of losses. The third research methodology that performed was sensor measurement. We have conducted the sensor measurement, which involved monitoring D-shaped optic fiber between white light source and the refractive index sensor with different type of substance which confer different value of refractive index applied to the exposed D-shaped fiber. The result displayed at the attached computer on the graph of transmission wave against wavelength. The data collection and analysis process include recording console simulation results. Secondly, the amplitude and reading of the signal can be monitored through specialized equipment connected to the computer. Fourthly, extract data from wavelength monitor. And finally, extract and plot graph from the sensor measurement. The following is optimized plasma simulation graph acquired from console multi-physics simulation. Wavelength against rho index, wavelength against external refractive index, external refractive index against rho index, transmissions against rho index, transmission against wavelength, and transmission against external refractive index. The following is gold dielectric metal simulation result from the console multi-physics simulation. The highest range is 30 nanometer thickness, which is 1600 volt per meter for maximum and 0.2 volt per meter for minimum. The lowest range was at 40 nanometer thickness, which is 250 volt per meter for the maximum and 50 volt per meter for minimum. Moving on to the second type of metal, which is copper dielectric metal simulation result for console multi-physics simulation. The highest one is same as gold, 30 nanometer thickness, 1400 for maximum and 0.2 for minimum. The lowest range was 40 nanometer thickness, 60 volt per meter for maximum and 20 for minimum volt per meter. The final type of metal was silver. The following is silver dielectric metal simulation result generated from console multi-physics simulation. The highest one is at 10 nanometer thickness, which is 450 volt per meter for maximum and 50 volt per meter for minimum. The lowest range was at 40 nanometer thickness, which is 80 volt per meter for maximum and 10 volt per meter for minimum electric field. The following is wavelength monitor result from 2 dB loss reduction from the D-shaped fiber. Moving on to the second wavelength monitor result, which is 3 dB losses reduction. The following is Gantt chart of activity, splicing and polishing, wavelength monitor, computer simulation, sensor measurement and equipment setups. My thesis currently documented introduction, problem statement, literature review, performance methodology and several acquired results. Several research activity hasn't recorded yet, as the research activity process hasn't finished yet. For the next semester, I intended to perform another set of computer modeling, simulation and fulfill the implementation of surface plasmon resonant D-shaped fiber sensor.